Our essential question in this video is, how do you find the length of a circle arc? And this may sound a lot like what we've done before, but I want to caution you, it is something different. We have found the measure of an arc, which is in degrees. Today we're going to go through the process of finding the length of a circle arc. And after you write that essential question, if you just bounce here on the bottom of the page, if you can fit in your margin right here at the bottom of this section, arc measure is in degrees. And your arc measure is going to be somewhere between 0 and 360 degrees is the measure of an arc. It's the same as measuring an angle. However, the length of an arc is something different. The length of an arc is like taking a tape measure that has a curve in it and actually measuring how long that arc is. So arc length is in units. If this circle was being measured in inches, it'd be in inches. If it's in feet, it would be in feet. So the length of an arc is using a tape or some kind of a device to actually figure out how far it is from one point to another in units of measure. Whereas arc measure is actually like an angle measure. It is in degrees. So keep that in mind as we go through this. So for our first example, we've got a circle here. Let's go ahead and put a radius in here. And remember from our initial videos, the radius of a circle is the distance from the center of the circle to a point on the circle. And we're going to label that with a lowercase r. Alright, and here's what we're learning in this first square. The circumference of a whole circle, the whole thing around this circle, is found with the formula circumference equals 2 pi times the radius. 2 pi times the radius. So in this example, if this radius of this circle happens to be 8 feet, then the circumference, or the distance around this circle, would be 2 times pi times r, which is 2 times pi times the radius, which is 8. And then class, I want you to realize, just like when you deal with variables, you always put the variable last. Like if you had a t times 5, you'd say 5t. If you've got pi in an equation, you put pi at the end. So this is 2 times pi times 8. We can multiply the 2 times the 8 and get 16. And then pi is going to be on the end of that, just like a variable. And then we're going to go ahead and label the unit of measure is feet. Now, be aware, I want to make sure I don't miscommunicate. Pi is not a variable. Pi is a representation of a number. And that number happens to be, if you remember section number 1 of your flip book, pi is the ratio of a circle circumference divided by its diameter. Circumference divided by diameter. So don't think of pi as like it could be any number. Pi is a specific number. If you put it in your calculator, remember you get something around 3.14. So here's how we find the circumference, or the total distance or length of the circumference, or distance around the circle. So in this case, when we figured out the circumference of this circle, we could say that their circumference is 16 pi feet, and that's the exact answer. But we could also estimate this by converting pi to a number, and we can do that in our calculator. So if you take a look at this, you're going to see on your calculator you have a button that represents pi. I've got mine right, where is that thing hiding? Right here. So I could type in 16 pi, and when I press equal, I'm going to get a estimated decimal answer, 50.265. I can round that to 50.3, and I could say that the distance around this circle is approximately 50.3 feet. So when you get the radius of a circle, if you leave pi in the answer, that's the exact answer. If you convert it to a decimal, you're going to get an approximate answer. It's close but not exact. Okay, let's take a look at the next box now. So now we know how to find the entire circumference. How do we find a piece of the circumference, which would be an arc? Remember, an arc is just a part of the circumference of a circle. So let's go ahead and draw a problem and see if we can figure this out. So I'm going to go ahead and we're going to draw a radius here. Let's go ahead and draw a radius here. Let's label some of these points. So I'm going to label this point E. Let's label where this radius touches the circle, point D. And then where it touches the circle over here, we're going to label that DF. And let's say that we're told that angle DEF is 88 degrees. So that's a central angle because it's made at the center of the circle. And let's also say that we're told that the radius of this circle is 3 centimeters. So we're told all those things in this problem. Okay, question is, how do we find the length of arc DF, the length? We know the measure of arc DF is 88 degrees because that's a central angle, and that means the measure of arc DF is the same as the measure of the central angle. But we don't want the measure, we want the length. And here's how we do it. Step number 1, find the whole circumference. We know circumference is 2 pi r. It's going to be 2 times pi times the radius, which is 3. Remember, we can multiply the 2 and 3 together and we get 6 pi, and our unit of measure is centimeters. So there's our whole circle, the length all the way around the circle. Now watch how this works, class. We get to use ratios for this part. Since angle DEF is only 88 degrees out of 360 degrees of the entire circle. Think about this. This piece right here, this angle DEF, this is 88. That's 88 out of the total circle, which we know is 360. And that is a ratio. 88 out of 360, or 88 of 360 degrees. All right, and if we know that that's how much of the circle is represented by this angle, then we know that's how much of the circumference is represented by this arc DF. And to find the length of arc DF, we just take the whole circumference, the whole thing, and we multiply it times how much of the arc we want. We just want 88 degrees out of a total of 360. And we're going to multiply those two things together. So the length of arc DF, and you'll see there's my arc measure, our arc symbol that we talked about. The length of arc DF is equal to the circumference, which is 6 pi. Let me move this down a little bit so we have a little more room. Okay, it's equal to 6 pi. There's our circumference of the whole circle times 88 divided by 360. And now we can just put that in our calculator, and we're going to get an approximate value. Let's put the whole thing in our calculator. 6 pi times, and in parentheses, actually you don't even need the times. I can backspace on that. You can just do 6 pi. Well, let's put the times in there, because that's what we wrote over here in our equation. Times, and in parentheses, 88 divided by 360. There's our, whoops, let's get that right, 88 divided by 360. There's our ratio of how much of the circumference we're looking to measure, or to get the length of. Press equal, and we get 4.607. That can be rounded to 4.6. And we've got approximately 4.6, and our unit of measure is centimeters. So the whole circle is 6 pi. The part we want, DF, is just 4.6 centimeters. Alright, so there's how you find the length of an arc. Figure out how much of the circle you want, multiply the whole circumference times the ratio that represents that little piece, and you end up with the length of that piece. Let's go ahead and look at another one. Okay, so the question is, what is the length of arc DF? Let's do another example. Let's go ahead and create an arc DF. So you're going to go ahead and draw a couple radii. I'm going to open that up a little bit more. Let's go ahead and label some points on this picture. So let's label that as D and this as F. We'll label the center of the circle as E. And let's say they tell us that this is 95 degrees. And they also tell us that the radius of this circle is 12 centimeters. All right, so we want to know how long is it? If we took a tape measure on this, if we figured out how many units this is, how many units is there? What's the distance from D along this circle to point F? Well, the first thing we do is find the whole circumference. The circumference of a circle is 2 pi r, which is 2 times pi. The radius is 12. We can multiply 2 times 12 is 24. Pi stays there, don't lose that. And then our unit of measure is centimeters. So the whole circumference is 24 pi. All right, how do we just get df? It's no problem. I'll change colors here. The length of arc df is equal to the entire circumference times the part of the circumference that we want to look at. Now think about this again. If the central angle DEF is 95 degrees, then we know that DF is also 95 degrees. And in fact, we could have labeled over here, class, just so we don't forget. We could have labeled that if DEF was 88, then we know that DF is 88 degrees out of a total of 360. So same thing here. We know that arc DF is 95 degrees out of a total of 360 degrees. So all we got to do is multiply these two numbers together and we will get the length of arc DF. So let's go ahead and do that. So arc DF is equal to 24 pi times 95 divided by 360. There's our ratio, or our portion of the circumference that we want. And let's put that in our calculator again. I'll move this over so we can see it. So we've got 24 pi times, and in parentheses I'll put 95 divided by 360. And we press equal. You got 19.89. We can round that to 19.9. So approximately 19.9, again, centimeters. So easy to find the length of an arc. I want to keep saying measure of an arc, but that's different. Measure of this arc was 95 degrees. The length of this arc, or the distance from D around the circle to F, is 19.9 centimeters. All right, last one, last example. A pizza with a 22-inch diameter is cut into 6 equal slices. 6 equal slices. What is the length of the crust for one piece? Well, think about the crust, class, as part of the circumference. Let's just pretend the crust is around the pizza, and we're just looking for the part of the pizza, the part of that piece that represents the crust, the part of the circumference. All right, well, we got to be careful on this one because they don't give us the radius. They give us the diameter. We know the radius is just the diameter divided by 2. So if the diameter is 22, then 22 divided by 2 is 11. So the radius of this pizza is 11 inches. Okay, we need to know that first so we can find, actually, you know what, let's just find the whole circumference right now. The whole circumference is 2 pi, and the radius is 11. 11 times 2 is 22. Pi doesn't go away, and then we've got our unit of measure is inches. So we know the circumference is 22 inches. That's how much crust we have around the whole pizza. Now we got to figure out the part of the crust that represents one piece of pizza. And I'm just going to visualize this for you. Let's go ahead and divide this pizza up into 6. Let's try and do it into 6 equal pieces. It's not going to be perfect, but we know these are going to be equal slices because it says equal slices. I got 1, 2, 3, 4, 5, 6. And I only want to know the crust of one of these pieces. So I just want to know how far is it from this point to this point. I want to know what is the distance from the edge of this pizza crust to the other side of the edge of that pizza crust. Well, here's a cool shortcut. In the previous two examples, we used degrees to figure that out. How many degrees were represented by the arc that we wanted to find the length of? In this case, we know this pizza is divided up into 6 equal slices. So we know that one piece is equal to 1/6. Look how we're using ratios and fractions again. 1/6 of the pizza. Because we know that one piece, this one piece right here, is 1/6 of the pizza. So here's what our equation can look like. So we can write the length of this crust is going to be circumference. Let me do this in a different color. It's going to be circumference times, and our fraction now is just 1/6. If you think about it, this piece right here is just 1/6 of the whole thing. So if we take the whole circumference and then just take 1/6 of it, we're going to get this piece right here. So let's go ahead and do this. The circumference we figured out was 22 pi. We know we're going to want 1/6 of that. Let's put that in our calculator. So we've got 22 pi times 1 divided by 6, and that equals approximately 11.5 inches. Approximately 11.5 inches. Okay, now if you think about this, what if you wanted 2 pieces? What's the crust of 2 pieces? It'd be the circumference times 2/6. What about 5 pieces? If you divide the pizza into 6 equal pieces, and I want the length of the crust for 5 of those pieces, I would take the circumference and multiply it times 5/6, because that's how much of the circumference I want the length of. And your final answer would be a sentence. You could say the crust of one piece. The crust of one piece is approximately 11.5 inches. So here's how you can see, hopefully, the strategy for finding arc length. We're using ratios and how much of the circle circumference we want to figure out how long that particular arc is.